Okay, share screen. Okay, I can see. And
Yes,
now you paint.
can see.
Okay, you can take your textbook. Okay, page 46. Okay, yesterday actually there's one more example. I didn't go through. That's why I didn't ask to do all the questions in your exercise. Okay. So look at example 9. Okay, given this y equals x and then square root and then x plus 3. Okay, this one x and in between the x and the square root x plus 3 here is times. So you use the product rule. So, okay, find the expressions of a dy dx. Okay, so part A, okay, differentiate this. Okay, so you let u be the first expressions. Okay, and then you let v be the second expressions. So second expression, instead of the square root, you write power half. Okay, then as usual, okay, du dx. Okay, differentiate x, so you get 1. Okay, then dv dx. Okay, differentiate this, you get bring down the power, the half. Okay, copy back the brackets. Okay, the index are -1, so half minus 1 negative half. Okay, and then remember to differentiate the one in the bracket. So when you differentiate this, you get 1. Okay, so you can just leave it. Okay, then this one you can rewrite. Okay, 1 over 2. So the 2 at the bottom, this one negative, that's why the whole thing at the bottom, and then half is the square root. Okay, so x plus 3. Okay, so dy dx. Okay, so you remember the cross. Okay, product rules is plus, remember. Okay, so this x times this. Okay. So x 2 square root x plus 3. Okay, then plus, okay, this times this. Okay, so this one you can write back as x plus 3. Okay, if these two you want to combine, okay, it seems like yesterday what we did. Okay, so this one is over 1. Okay, so times with square root x plus 3 over square root x plus 3. Okay, maybe with the 2 also, because here got 2. So 2 and 2. Okay, so now these two terms has the same denominator already. Okay, so I can combine it. Okay, first term is x. Second term is this times this. Okay, so I have a 2. Then remember the square root a times square root a is the a. So x plus 3. Okay, then this part you can expand and combine. So 2x, 6, and then this one just copy. Okay, x plus 2x is 3x. And then 2x plus 3. Okay, last step here you can how to say factor out 3. Okay, so left x, left 2. Here is 2. Okay, square root x plus 3. Okay, so same as in your textbook already. Okay, next part. Okay, other than that, part B, you have to find the gradient of the tangent at x equal to 6. Okay, when x is equal to 6, okay, find the gradient of the tangent. the gradient of the tangent is the dy dx. This is beginning of the chapter we learned. Okay, what is the meaning of dy dx? Dy dx is the gradient of the tangent, okay, of the curve. Okay, so when they ask the gradient of the tangent, it means dy dx. Okay, but it will give you at different point. So for the part B, they are asking and when at x equal to 6. Okay, so for part B, okay, when x equal to 6, okay, or at x equal to 6, so same thing, okay. So your dy dx, which is the gradient of the tangent, is equal to, okay, so now the x is 6, so replace the x with 6 and then find. Okay, so you will get a number 2, this one 6 plus 3. Okay, so this is 3, this is 8, and then this is 2, this is 9. Okay, square root of 9, you get 3. Square root of 9, you get 3. So here cut, here cut. Therefore, the answer is 4. Okay, so you can write, okay, gradient of tangent, okay, at x equal to 6 is 4. Someone write something, is it? What page? Dashna. Okay, page 46, Dashna. Dashna, okay or not? Okay, now I have 21. Okay, very good. Why is still blinking? I don't know why. Okay, I go back here. Any questions? Dashna here?
Yes, good morning.
Okay. So you missed that part, never mind. Okay, afterwards you watch the video,
Yeah, no problem. Okay.
Okay, so I continue. Okay, now we go to another subtitle already. Okay, I go to your textbook. Okay, so you write inside your MS2. Okay, remember to ask your parents to help. Okay, to pass the MS1 to the school house. Okay, so this is today index. Okay, in your MS2. Okay, the second derivative. Okay, first derivative is a dy dx. Second derivative means on top of this dy dx, you differentiate one more time. Okay, means the function itself you differentiate 2 times. Okay, this is the meaning of the second derivative. Okay, then afterwards for these applications, first derivative has a meaning, then second derivative has some meaning. Okay. Okay, so you look at these functions. You look at these functions. Okay, first derivative means you differentiate one time. Okay. So you see cubic function of the x, the highest powers is a cube. It will reduce into square. Okay, quadratic function of the x when you differentiate one time. Okay, so you know that if you differentiate one more time, it will reduce some more. Okay, so it will become a linear. Okay, you go through the text a while. Okay, notice that differentiating a function y equal to fx with respect to x will result in another different function of x. The function dy dx or f prime x is known as the first derivative of the function y equal to fx with respect to x. What will happen if we want to differentiate dy dx or f prime x with respect to x? Okay, mean you differentiate this one more time. Okay, when the function dy dx or f prime x is differentiated with respect to x, we get this. Okay, you see or not? This is how you write for differentiation. Okay, if the first time here is y, okay, but differentiate second time, here you write dy dx, mean you differentiate dy dx one more time. Or, okay, same thing, okay, you differentiate f prime x, the same thing. This function is written as, okay, I don't know how to read this. Wait, they sure or not how to read this. I will just read d square y, okay, over dx squared, okay, or f double prime x, okay, double prime, two times double prime x is called the second derivative of the functions y equal to fx with respect to x. Okay, so in general, okay, this is the meaning. Okay, so when you see this, you have to know what is the meaning. Okay, the d square y over dx squared, okay, this one means you differentiate dy dx one more time. Or when you see the f double prime x, you have to know what is the meaning. Means you differentiate the f prime x one more time. Okay, so this one you can write in your notes. Okay, what's the meaning of this? No, and what's the meaning of this? When you see this symbol. Okay, so straight away we go to the example. Okay, this is the function. Okay, this is the functions. Okay, you have to find dy dx and you have to find the d square y over dx squared. Okay, so I do in pen. Okay, let's start. Okay, this is example 11. Okay, part A. Okay, this is a function y equals x to the power 3 and then 4 over x squared. Okay, so first of all, you find dy dx. Okay, differentiate the first time. Okay, you differentiate x to the power 3. Okay, you will get 3x power 2. Okay, and then when you differentiate this, okay, before that, maybe this one I change into a index form. So 4, this one become -2. Okay, so now I differentiate this, I get 4. Okay, bring down the power. Okay, the power minus 1. -2 minus 1 is -3. Okay, so I get okay 8 and then x to the power -3. Okay, I think I will just leave it. Okay, I don't make it into fractions. Okay, so because I need to differentiate one more time. Okay, so now d square y dx squared is equal to, okay, you differentiate dy dx. Okay, means you differentiate this. Okay, so when you want to differentiate this, okay, differentiate the first term, 3 times 2, 6. Okay, then differentiate this, bring down a power. Okay, the power are -1, so -4. Okay, and then this one you can write in fractions. Okay, bring down x to the power 4. Okay, so this is the part A. Okay, now we go to the part B. Okay, if okay gx, they give you another functions. This is gx. Okay, 2x to the power 3. This is same like the example just now. Okay, it's a cubic functions. minus 9. Okay, so you know that after the first differentiation, it will reduce, become a quadratic functions. Then after that, after the second differentiation, it should reduce to the linear functions. Okay, so okay, first of all, they ask you straight away find g double prime 1/4. Okay, so before that, I got to find g prime x. Okay, mean differentiate the first time. Okay, 3 times 2, 6. Okay, power minus 1. 3 minus 1 is 2. 3 times 2, 6. Power minus 1. 2 minus 1 is 1. Okay, 1 no need to write. Okay, differentiate negative 7x, you get negative 7. Differentiate negative 9, you get 0. So no need to write. Okay, so after differentiate one more time, g prime x, okay, so you have a quadratic functions. Okay, next, g double prime x. Okay, on top of the g prime x, I differentiate one more time on this. Okay, so this one means differentiate g prime x. Okay, I follow the definitions. Okay, so differentiate this. Okay, so 6 times 2, 12. Okay, the power 2 minus 1 is 1. No need to write. Okay, differentiate 6x, you get 6. Differentiate negative 7, you get 0. Okay, so this is your answer. Okay, only you can continue to find the following. Okay, g double prime. Okay, now the x is 1/4. Okay, so just replace the x here with 1/4. But before you do this, remember, you must find the one in terms of x. Okay, so 12. Okay, x now is 1/4. Okay, so 3 plus 6. Okay, so the answer is 9. Okay, then second one, they ask for g double prime negative 1. So same thing. Okay, this x here replaced with negative 1. Okay, so 12, negative 1, and then plus 6. Okay, here is negative 12 plus 6. So the answer is negative 6. Okay. If any questions, you can stop me anytime. Okay, next I will go to example 12. Okay, you can look at your textbook, example 12. Okay, I open a new one. Okay, given the functions, okay, fx is a cubic function. Find the value of the x such that, okay, f prime x is equal to f double prime x. Okay, so we just follow, okay, the equations given. Okay, so we start with this, fx. Okay, x to power 3, power 2, 3x, and then plus 4. Okay, find the value of x. Okay, so you need f prime x and you also need f double prime x. Okay, so we just do as normal first. Okay, we get the f prime x first. Okay, so bring down the power 3. So power minus 1. 3 minus 1 is 2. Okay, 2 times 2 is 4. Okay, 2 minus 1 is 1. 1 no need to write. Okay, differentiate 3x, you get 3. Differentiate 4, you get 0. Okay, so this is a f prime x. So f double prime x. Okay, differentiate this one more time. 3 times 2, 6. Okay, 2 minus 1 is 1. Okay, differentiate 4x, you get 4. Okay, that's all. Differentiate 3, you get 0. Okay, now I'm ready with the f prime x and f double prime x. Okay, next, he say that let this equal. Okay, f prime x equals f double prime x. So 3x squared plus 4x plus 3 equals 6x plus 4. Okay, then they want you to find the values of x. Okay, this equation. Okay, solve it to find the value of the x. Okay, definitely this is a quadratic equation. So all the term move to the left-hand side. Okay. All this remain. Okay. This one move to the left, become minus. Okay, combine the like term. So 4x minus 6x minus 2x, sorry, negative 2x. Okay, plus 3 minus 4, so negative 1. Okay, after that you can factorize. Sure, so here 3x, here x. Okay, 1. Here you have a 2, negative 2. So negative 1 here and positive 1 here. Okay, negative, positive, you get negative. 1 times 1 is 1. Okay, here you get positive 1. Here you get negative 3. So it's negative 2x. Okay, so it's correct. Okay, so 3x plus 1 equal to 0. The other one, x minus 1 equal to 0. So x equals to 1. The other one is 3x equals to negative 1. X equal to negative 1 over 3. Okay, so you have two values of the x. Okay. So, okay, I want to go through one more part. Okay. Look at your textbook, page 51, after this example. Rest for a while. You want to go toilet, want to drink water? Okay, we come back at 8:30. Okay, now it's 8:26. Okay, rest for a while. Okay, now 8:30. Okay, we come back. Okay, we continue. Just now I see full attendance. Now become 22. Someone left already. Okay. Textbook. Okay, can you hear me? Someone on the mic? Can hear me? Can see the textbook?
Can see.
Okay, okay, very good. Okay, so if you look at your textbook, page 51, okay, so you all know already actually, we start with this dy dx, the differentiation is because of the gradient of the tangent. Okay, so we go through this part. Okay, we have already learned that the gradient of a curve at a point is also the gradient of the tangent of the point. Okay, these two things are the same. Okay, gradient of curve at a point, okay, is same as the gradient of the tangent at the point. Okay, these two are the same. Okay, the gradient changes at different point on a curve. Okay, what's the meaning of this? Okay, we look at this example. Okay, consider the functions y equal to x squared. Okay, and its gradient functions. Okay, this one we call it gradient function. This is very important. Okay, you should write in your notes. Dy dx. This one we name it gradient function, because always the question will start with given the gradient function, okay, is blah 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 blah, but then the student don't know what is the meaning of the gradient functions. Okay, if the question give you gradient functions, means dy dx. Okay, so this one is very important. Okay, you got to write inside your notes, and then put some marks on it. Okay, so okay, we start with this y equals to x squared. Okay, you differentiate this, you get 2x. So this one, okay, the dy dx, the differentiation of this, we call it gradient function, the 2x. Okay, the gradient function f prime x is used to determine the gradient of tangent to the curve at any point on the function's graph, okay, fx. So you know that dy dx means what? The gradient of the tangent or the gradient of the curve. Okay, for example, okay, for the functions x squared, okay, this is a function of x squared. Okay, now, okay, at different point, okay, at different x, at different point, okay, they try to find the gradient of the tangent, okay, by using the dy dx, okay, by using this function, the 2x. Okay, so when x is -2, okay, so 2 times -2, you get -4. When x is -1, 2 times -1, you get -2, okay, and etc. Okay, so you can see that at different point they have a different gradient. Okay, so now you look at this. You look at this graph. Okay, when x is -2, okay, the gradient is -4. Yeah, when x is -2, okay, the gradient is -4. Okay, so when x is -2, the gradient is -4. You can see the light blue color line. Okay, that is the tangent. Okay, that is the the gradient of the tangent. Okay, then when x is -1, okay, the gradient is -2. When x is 0, okay, the gradient is 0. Okay, when 0, you can see the slope, the tangent actually is a horizontal line. Okay, and then we continue. Okay, when x is 1, okay, the gradient is 2. Okay, and then when x is 2, the gradient is 4. Okay, so actually this one you know already. Last time we learned gradient for a straight line. Okay, when you have positive gradient, okay, you can see the line is slanting this way. Okay, you have a negative gradient, the line is slanting this way. Okay, and then when you have a zero gradient, you have a horizontal line. Okay, the diagram on the right shows the gradient of the tangent to the curve at the 5 different points. Okay, in general, the type of a gradient of tangent, okay, and the property of a gradient of the tangent, okay, can be summarized as below. Okay, so let us see. Okay, what's the meaning of a negative gradient? Okay, you see, the tangent line slants to the left. Okay, mean this way, slant to the left. Okay, when you have a negative gradient. Okay, same like last time you learned the straight line gradient. Okay, when you have a positive gradient, okay, the line will be something like this. So the tangent line slants to the right. Okay, slant to the right. Okay, how about zero gradient? Okay, horizontal. Okay, the tangent line is horizontal. Okay, so three types. Okay, we continue to the next page. Okay, it's an example. Okay, example 13. Okay, now we see how we do these questions. Okay, the diagram on the right show a parts of a curve. Okay, y equal to 2x plus 1 over x squared. And the point, there are 3 points, point A, point B, and point C are on the curve. Okay, find an expression of dy dx. Okay, so you got to differentiate this. Okay, so I go back here. Okay, you can have a book with you. So question 13. Okay, the function given is this. Okay, instead of 1 over x squared, I would like to write in index form. So it's -2. Okay, so part A, the first part, they want you to find dy dx. Okay, find dy dx. Okay, so okay, differentiate 2x, you get 2. Okay, then differentiate this, x to power -2, you bring down the power -2, okay, x, and then power -1. -2 minus 1 is -3. Okay, so you are getting 2 minus 2, okay, and then x to power 3. Okay, because negative, you write as the denominator. Okay, so this is what you get. Okay, after that, this is part 1. Okay, now for part 2, okay, the gradient of the tangent to the curve at point A, B, and C. Okay, the gradient of the tangent, okay, to the curve at the point A, B, and the C. Okay, find dy dx at the point A, point B, and point C. Okay, so for the point A is 1/2 and then 5. Okay, the dy dx is 2 minus, okay, x now is 1/2. For A, x is 1/2. Okay, so you replace the x with 1/2, the whole thing over 3. Okay, you can press calculator. Okay, you will get a -14. Okay, then for point B is 1/3 dy dx. Okay, same thing, 2 minus 2 over, now the x is 1. Okay, so 1 to power 3. Okay, so your answer is 0. Okay, now we'll come to point C. Point C is 2. 4, 1/4. Okay, same thing, dy dx. 2 minus 2 over, okay, x now is 2. Okay, so 2 to power 3. Okay, so the answer is 1/3/4. Okay, so this is for the part A. Okay, now we come to the part B. Okay, for each of the point A, B, C, okay, state the condition of the gradient of the tangent to the curve. Okay, so here, okay, the keywords here is state the conditions. Okay, state the condition of what? Of the gradient. Okay, state the condition. What's the meaning? Okay, so you see the answer. Okay, how you state the conditions. First of all, you see whether this negative is positive or is either 0. Okay, so for the point A, this is a negative. Okay, the gradient is negative. Okay, for point C, the gradient is positive. Okay, then For a point B, the gradient is 0. Then you say, okay, gradient negative, then is what? Okay, the tangent line slants to the left. Okay, its gradient is 0, the tangent line is horizontal. Okay, then the gradient is positive, the tangent line is slant to the right. Okay, this is how you state the conditions. Today we are running quite fast because I didn't ask you questions. If I ask you questions, then we run very slow. Okay, so I think I need to when we have time, only I come to the questions. So I want to make sure everyone answer the questions, especially always the few girls that I call name but didn't appear. I don't know what happened to them. You know, if you know suddenly maybe want to go toilet or whatever, afterwards you have to let me know. Like that day I remember Catherine, she said she want to go toilet. Then I know what's happening. If you just keep quiet, I really don't know you are learning or you are not learning. When I ask you to do homework also you didn't hang in. I will go through one more times. Siapa yang still hutang me the homework one, okay? I don't know how you want to answer my questions. Okay, so before that, okay, this is today homework. Okay, 2.7. Okay, and then we go back. Okay, 2.6. And then one more. Yesterday, the 2.5, we left 2 questions. Yesterday, the 2.5, but you left these 2 questions, number 3, number 4. Okay, so this is for today homework. Okay, now, this is quite difficult actually. Okay, maybe if you can do, okay, then it's good. Okay, if you cannot do, I don't know, I really don't know. Okay, let us see who didn't have any homework yet. Okay, and then PBD also, you see, even I give a test also don't want to do. I don't know how. Okay, you have to let me know. Okay, how I can help you. Maybe I put in the Teams is not a good way of doing assessment. Okay, so Aksa and Ravania. Okay, Aksa left already. I don't know what's happened. Okay, Ravania. Ravania here. Ravania. Ravania. Yeah, Ravania. My goodness. I really feel like, we are wasting the other people time long. For those running very well in this subject. Ravania. I mean, if you are friends of these 2 girls, Aksa and Ravania, okay, talk to them. They didn't show me that they are putting effort. Okay, I'm in front of the class also I will say the same thing. I don't want to private talk to them already anymore. Okay, I'm so I got that time to go through talk to if I have a 10 student have problem, I had to talk to them one by one. Okay, let us see the homework. You see the same name. Okay, you see this. January 29. Whoa, my goodness. I reminded how many times already. Same name, Ravania. Okay. Okay, let's see this. February, 3rd of February. This is half a month ago. I have reminded her. She had promised say yes, she will hand in. Until now, Aksa. If you hand in already, but then I cannot find. Okay, you have to help me. Okay, because sometimes you hand in, I don't know where you hand in. Okay, inside the Teams. I cannot find. You have to let me know. Okay, where to find it. Okay, one more. I don't know whether this girl aware or not. Okay, 5th of before Chinese New Year, 5th of February. Okay, this is sorry, I having class after I call you. Okay, this is Farah. Is Farah here? Banyak marah. Yes, okay. Can you please tell me you hand in already or not? If you don't know what to hand in, you go to our post, okay? Not yet lah. Yo, Farah. You have to tell me the problem. Cannot do? Tell me a reason. Yeah means what? I will try do. You try do. You know, every lesson I give homework, you are piling up, okay? You are accumulate all the homework. Okay, Aksa didn't come back. But Chong is here. Okay, Chong, you replace Aksa lah, huh? When I ask question, you represent. Okay, so we start with some questions. Maybe I'm thinking you're wrong. You can answer the questions, then I give you 1 mark. You know, you accumulate the mark. And not here 1 0 mark lah. Okay, then maybe you know this one will give you some marks in during your exam or what, contribute some marks. Only fair correct or not? Okay. Where am I? Okay, go back to the textbook. Okay, this is what page? 2.2. Okay, page 48 if you have your textbook, page 48. This is formative exercise 2.2. Okay, question number 1A. Okay, differentiate each of the following expression with respect to x. Okay, so I let this be y. Okay, I help you. Okay, change this into a negative index. Okay, so dy dx. Okay, so the first one, wait. Okay, Aksa not here. Catherine.
Yes, teacher.
Line. You do for me the first term. Differentiate 9x squared.
2 times. Wait, why echo?
Apple? Where got apple? This is question number 1A. 9x squared. You do for me this only. First term.
2 times 9.
Yeah.
X. 2 minus 1.
2 times 9x and then 2 minus 1.
Yeah.
Okay. So what do you get for this?
18x.
18x. That's all?
Yeah.
Okay, right, okay, next, Dashna. Chiong,
Teacher still echo ah?
huh?
Got echo or not? Nah, it's okay, it's okay. Okay, ready.
Father voice, I can hear your family voice. Dashna?
Yes, teacher.
Okay, continue for this term, the second terms.
Negative 3 times negative 2 is plus 6.
Then?
X
Uh-huh.
the power negative 2 minus 1.
Okay, very good. Okay,
So
plus 6.
below
Mm.
x negative 3 power negative 3.
Okay, very good. You see, if I ask question, you are able to answer, huh? I think no problem for you to solve your homework. Okay, so this power negative 3 at the end you just change to become the denominator. Okay. So Catherine, Dashna, you are getting 1 mark, 1 mark. Okay, now we come to question B, 1B. Okay, 6. Okay, same thing. I write 6. Y equal to 6 over x to power 3, 1 over x plus 8. Okay, dy dx. Okay, so this one I write negative 3, okay, negative 1, and then 8. Something wrong, okay? Not dy dx yet, I not yet differentiate it. Okay, Farah, you got no mark, so you type lah. Okay, differentiate this. 6x to power negative 3. What do you get? Okay, I give mark first. Okay, Catherine getting 1 mark. This one missing, getting 0 marks. Okay, Dasna getting 1 mark. Okay, now waiting for Farah. Farah say what? Negative 18x and then power negative 4. Negative 18x to the power of negative 4. Okay, let me see. Okay, this time this is a negative 18. Okay, and then x to power negative 4. Okay, ma, you can do, ma. Then your homework, why you cannot do? Okay, so very good. Farah, you are getting 1 mark. Okay, then next girl will be, okay, maybe I jump queue a bit. Okay, Siti Farah, are you here?
Yes.
Okay, Farah getting 1 mark. Okay, now it's your turn. Siti Farah. Okay, can you continue? Okay, second terms, this part here.
Positive x power of negative 2.
Positive x and then power negative 2. Very good, you see? All can respond very well. Okay, last term, okay, 8, when you differentiate, you get 0. Okay, so this one, I rewrite into a fractions form. So I get negative 18 and then x to power 4. Okay, this one I will get 1 over x to power of 2. Okay, so this is question B. Okay, I continue.
Teacher.
Yes, I make something
Can
wrong.
we? No.
Yeah.
Can we jump to question G?
G, you like G, okay. G, very good. Okay, wait, I give Siti Farah 1 mark first. Okay, next is Sophia. Sophia here. Okay, G, wait, I write the questions first. Okay, this is y equals, okay, 4 over 9, and then x to power 3. Oh, you scared of the pi, is it? Okay, so before that, this one I want to change into a negative index. So 4 or 9, leave it. Okay, x to the power negative 3. Okay, x and then 6. Okay, so this is y. So dy dx. Sophia here. Okay, I think she typed. Teacher, I want to go toilet. Okay, go, Catherine. Okay, Sophia here. Oh, Sophia. Sophia. Okay. Can you answer this question, Sophia? Okay, you do for me the first term. Differentiate this. If you cannot, just say cannot. Don't waste other people's time. Other friends, please, don't help her one. Don't go and WhatsApp her the answer. Yo, what burning? Oh, okay, come already. 4/3. How you get 4/3? Okay, wait for a while. It should be negative, lor. You write negative or not? It should be negative, lor. Okay, wait. Okay, 4/9. Okay, bring down the power -3. Okay, then x, then the power -1, -4. Okay, so you see or not? Here you have a negative. Okay, this is 1, this is 3. Therefore, this one should be negative 4/3. And then x power -4. Okay, so you miss out the negative. Okay, never mind, Sophia. Okay, good try. Okay, you just miss a negative. I still give you 1 mark. Okay, Dashna asked me this question is because of the second term. Am I right, Dashna? You have doubt on the second term, is it?
Yes.
Okay, you assume the pi is just a number. Okay, so let's say this is -3x. If you differentiate -3x, what do you get? Dashna.
Yes, yes.
If you differentiate -3x, you just assume the pi as a number. So you
Negative
3x,
3.
-3. If this is -5x, then
-5.
if this is -pi(x), then so -pi lor. That's all. Okay. Then the
Actually, no
6
need to substitute that.
substitute what?
3.141.
No.
Okay.
Unless the final answer is come out with a value. Okay, maybe afterwards they'll ask you to substitute x and as at a certain point then only you replace the pi with the 3.142. Okay, if not just leave it. Okay, and then last part for the 6 you get 0. Okay, so this one continue. Okay, this one I rewrite it in this form, fraction form. Okay, so this is the answer. Okay, so I will have to remember to give for Sophia 1 mark. Okay, Sophia 1 mark. Okay, I think that's all for today. Now it's already 8:55. You have another class to go. Wait for a while. Okay, I got to stop record.